Yeah, this startup is coming from Hamburg. They are called Process.Science. Their presentation shows how AI can turn raw sensor data into actionable process knowledge, a super important topic for our industry, regardless of what production you're having, in order to make production more transparent and efficient. I'm super happy to announce him here on stage. Please welcome with me, with a big warm applause, Lukas Maximilian Schroth, who's Executive Manager at Process.Science. Lukas, stage is yours.
Thank you. All right. So I have a question for you guys, because I'm a huge aviation fan, and maybe you guys want to raise your hand if you're also like into Airbus and Boeings, and I know at least one guy. Ah, yes. Okay. Why do I ask it? Imagine yourself sitting in an airplane, and you have this huge cockpit in front of you with all the different informations, with all the different sensors, with everything that is showing you how well is the plane doing at the moment. Yeah, so how good are you on time, are you on track, what is fuel consumption, everything. That is, for an airplane, it's standard that you have some sort of cockpit, some sort of dashboard in front of you. But what is it that you have in your daily operations for your processes? Do you have something the same for all your purchasing processes, for your manufacturing processes, or your logistics processes? Is it a dashboard that you have in front of you, a cockpit that is telling you, is my purchasing process good? Is my vendor here giving me a good lead times, good delivery times? Most of the time, I would say no. And today, I want to also bring in the topic of all kinds of sensor data that you have in your manufacturing. So I want to talk about from sensor data that we are tracking, if we look at all the different vendors out here all the time, to real process insights. What is it in today's world? Yeah, so like I said, we have a lot of vendors out here. We just need to look around, all the different machines, all of them today are equipped with sensors. They do track what is happening. Now we have around 50,000 sensor points per machine per hour. We use roughly, based on what I found, is roughly 5% of these sensors for real process optimization. Everything else, is left in the data grave. We don't do anything with it. And what we want to change is that we use this data, and not only for predictive maintenance, when do we need to change something in a machine, but also in the full end-to-end process, from sales order to manufacturing order to logistics, to use this sensor data in the middle to give a full end-to-end process view and give companies the ability to analyze and optimize their processes. So, in a world where you don't use the data, what is happening when you ask yourself, how is my process running? Where do I have problems? I used to work as a SAP consultant before founding Process.Science. And what happened is I came into a company because they had the need of getting information about how their ERP processes are running. So you go to the different departments, you go to the different people, and you talk to them, how is your process running? They might come up with a process manual, hopefully. They have some sort of booklet that will tell you, I see some lefters in the last row, so that's why, hopefully, that's not all the time that it's there. There's something telling you, it should be this way or this way, and it's very linear. It's not really taking in action all the different procedures that are there for different material groups, for different vendors, for different purchasing groups. So we go to process interviews. We go to the different departments, we talk to the different people, and we ask them, hey, can you tell us how is your manufacturing process for this specific material group? How is the purchasing going in general? How is your sales orders flowing through your system, through your company? And yes, it works. You will get some information out of it. You will get, let's say, something 30 to 60% of how the process really looks like. But it's a very subjective information that you will get. And it's definitely going to be not all of the information, because people, and it's not because they are bad and they don't want to tell you, but they are going to leave out specific information. So what we do is we use data that is already there in the different systems, in the ERP, in the EMS, WMS system, to analyze and visualize the full end-to-end process, from sales order to production order, purchasing order, and the inbound-outbound logistic, to really show how the process is running. And that is called, and some of you might have heard, it's called process mining. That's already out there, and companies are using it. What it will give you, it will give you a real end-to-end view from, let's say, a lot of manufacturers out there. Sales order comes in, it will be tracked by the ERP system. In the best case scenario, or in some cases, you have everything in your warehouse and you just need to ship it. Next step might be you need to manufacture something. So out of the sales order, it will result in a manufacturing order, a production order. And then it will be a case where you also need to purchase something from your vendors. So you already have 3 departments included in just one end-to-end process of manufacturing one part. So that is where process mining will help you and give you the ability to really show the full end-to-end over all the different departments. And like I said, that is already happening in today's world. So that is where we are today. And if we just look at some of the results, some of the companies, there are some of the companies that are already using the process mining solution that we offer today. Of course, you see manufacturers, you see, I think there is also some consulting companies, but of course, manufacturing is a huge part where it comes in handy with all the different departments going hand in hand, but not always talking to each other. But with this, you have this top-down view with all the different departments, all the different, let's say, problems, and where you need to take action. And you see efficiency increase, average what we see in our clients, 15 to 25%. Also lead times, so the time from the beginning of the process to end of the process, going down by 30 to 50%. And also compliance improvements. If we talk about purchasing, you have this phenomenon called maverick buying, where someone is calling the vendor, telling them, hey, or the supplier, hey, I need material A. They will ship it to you, and before or at the time when it's arrived, you don't even have a purchase order in your ERP because they forgot. It might be fast, but it's definitely not compliant. And if some internal auditor or someone will look at it, they will tell you, hey, what is happening here? And that is one of the demos that I included. So this is how some part of the solution looks like. Like I said, it's a dashboard. It's a cockpit of all your different information that is necessary for your company, for your different departments. So what do we, and where's the, so we see on the left side, we see the full end-to-end process. We also see 116,000 order positions. So this is data from 1 year, 116 purchase orders. So we are looking at the purchasing process. And then we have some information about different suppliers, purchasing groups, and also about so-called activities that are deviating from the target process, so from our process manual. And if I start the video, what we are doing is we filter for all the purchase orders that are completed, so that are paid already. And then we are looking at price changes in the process. We see time goes up by 20 days, we still have 2,000 order positions and an order value of 1 billion, where we had price changes and we paid after 50 days. Ask your supplier if they will give you a cash discount after paying 50 days, which normally have like 15 or 30. And with only like the first thing is the dashboard, showing you the information, giving you the ability to ask these questions. And the next step, that's where machine learning and AI will come into place. It will show you the main problems, the main influence factors for, in this case, price changes. It's specific purchasing groups, it's specific product groups in line 3. It might be a combination of both. And as a manufacturing or as a purchasing head in this case, you are able to ask questions very fast to your team and ask them, hey, why are we changing prices so often for this specific product, for this specific supplier? So really asking the right questions to the right people, that is what the software will enable you to do, or process mining in general. But like I said in the beginning, it might be for manufacturers. Purchasing, then we have manufacturing in the middle, we have or sales in the beginning, and then logistics in the end. What process mining currently is good at is taking data from ERP systems, from EMS, WMS systems. What we did not do till today is take all the different sensor data that we collect all the time from all the different machines. So everything that really happens on the shop floor is a complete black box. Because all the different sensors, we do track them, but there are millions of combinations. And as someone looking at these combinations, like how hot is the oven, how fast is a conveyor belt moving, in which direction is it moving, it's not really something that we can talk to someone in like the ERP side manufacturing department, because they will not understand. So what we will do is we will use all the different sensors and create the process behind it with the activity names. So is someone using, is the machine drilling, or is something going to be cut, is something going to be melted, based out of the different sensors and the different combinations that are there in the combination of sensors and machines. So what are the tasks for that? We now have, let's start with like 50 machines on our shop floor. We have a manufacturing order that comes in. We might know for the manufacturing order, we might know the sales order. We know it's sales order number 1. When it hits the shop floor, we might be lucky and we can track the sales order from the beginning to the end. I know from companies, from clients, that they are not. And I'm not talking about companies that just started having big machines in their manufacturing, but I'm talking about companies that are far up the right side when it comes to digitalization and everything. And they still have the problem of, how can I identify the case? The case like being this one sales order all the way down to the end. So this is like the first big problem. Then the complexity from all the different sensors. Like I said, there are millions each day, millions of sensor data that we track each day, and all the different combinations that we have for all the machines. Mapping these combinations to one activity, like we are drilling something, we are drilling this part, we are melting this part, is months of manual effort if you give someone the task to create a mapping for, okay, if combination A, B, C is there, then it's activity Y. And like writing a rule set that will cover all your combinations. When you're having 50 machines, let's say all of them have 50 different sensors, I mean, do the math with all the combinations that you have and then giving someone the task to do this manually. So that is where AI comes into place. Yeah, so machine learning, AI in the world today, we can use to really do all this manual work, automated in minutes. So what is happening? We will use all the different, we use the data that has already been tracked. Yeah, so all the different sensor data, so technically speaking, timeline series data. So at this second, this machine sent this combination of sensors. It will go into the software and it will create, and now it's going to be a little bit technical. So if you have some questions later on, I'm not really angry at you at all. It will use different machine learning algorithms to cluster all the different combinations. Because not all the combinations, not all the sensors are relevant. There's something at this point that might be relevant later on, but not in this combination. So it will create different groups. Yeah, so this combination is one, this combination here, and so on. That's the first step. That is where machine learning algorithms come into place to really cluster the data. Then it will analyze the clusters and find the relevant ones. So based on how often do we have clusters, they are ones that are in the target process, in the process that is happening the most, and the different activities that are happening the most. You might have clusters that are frequent, but they are not so frequent like the ones on top. So they are not going to be lost because they might be some outliers. They might be some rework that is happening in the process. And then afterwards, if we have the different clusters, we analyze them, we prioritize them, we will use a description of the process. So that's where the so-called human in the loop comes into place, where you have someone explaining the process that you're doing. So I'm a manufacturer of windows, and I have cutting machines, I have some sort of other machines to really describe what is happening. Best case scenario, I do have a process manual that I can upload into the software. And what will happen is it will label the different groups, and it will give these different groups labels that can be analyzed by business analysts in your company. Yeah, so people that do know how the process should look like or looks like. And it will be then some sort of, so there's like a technical view of it, database view of it. It will have the case included, so which sales order is this one combination limit or bound to? What is the activity name? So for example, this is from a sales perspective, so payment. At which time, what are specific attributes? So for example, temperature of the machine, or in this case, what was the cost of this activity when it was performed manually. And this will then directly go into the already existing process mining solution that I've shown earlier. Yeah, so this black box of all the different sensors, all the different machines, we now translate it into process activities, into different steps of the real process. And if you talk to someone that is part of this process, you can talk to them, not saying, hey, we had combination A, 1, C, 2, and so on, but talking to them that, hey, this activity occurred. Why is this activity occurring 3 times if we produce something from material group 1, 2, 3? So what we did, and I mean, there are a lot of machines out there that are very huge. We are a software vendor. We are not able to have like a machine that is something like this, even to my left. But we bought a Fischer Technic factory. Some of you might know it's like a small factory. It's so big or so little, whatever you want to call it, and it will track all the different steps that are happening. So when I start the video, you will see that it has an oven. Yeah, so it will simulate how hot is the oven. Then it has something to move the part that is being produced from A to B. And in the background, it will track all the different information from all the different sensors. And it will write it to a database. So that's what's happening in a normal manufacturing environment with like big shop floors, many different machines. And now the data is in the database and will be analyzed by the IoT miner. It will create the clusters, we will describe the context, it will give you an overview of what clusters have been generated, what activities did we find, and it will generate the so-called event log that will normally be used for process mining solutions in general. Yeah, so we see saw operations, conveyor operations, and this all will go into a dashboard that you've seen earlier, with activity names like the oven feeder reached the inside position. It's something I can talk to someone and telling them, hey, what is happening here? Why is this taking so long? And not a conveyor belt, direction right, and moving with 5 kilometers per hour and whatsoever. Yeah, it's something I can talk to people and have different information about what is the time between these activities. So what is my idle time between activities where the machines are not moving, and then how long is the activity duration for something. Yeah. So what did we achieve with having included all the different sensor data from the shop floor into our normal process mining or automated process analysis? Is we will have the full end-to-end process from sales order, purchase order, everything in the shop floor, all the way to the outbound logistics process. Yeah, so like I said, like we saw the different process analytics. So how does the process flow look like? What are different patterns? What are different ways? And then also the anomaly detection that I've shown earlier. This root cause analysis. So what are different views on it? So how did my process cost change in relation to last year, and what are main influence factors for it going up? So we have science in our name, yes, so Process.Science. So yes, we do have a background. One of our founders has a strong background as having a PhD in process mining in AI. So we always say like everything we do comes from our laboratory. But of course, this is the one side. But companies out there are the other side. And trying to bring them together is always the big thing in having new, especially software development. So we have 3 great partners out there. One is the University of Krakow that we are working together with for this IoT miner and all the AI components of it, because they have huge knowledge, especially in data mining and AI. And then we have 2 companies from the real world, both being manufacturers. One is Ocnoplus, they are producing windows, and the other one is Liebherr. You might know them with all the big cranes, or some might know them from the fridges. And they are using what we've built with the IoT miner to give direct feedback. What is it that is positive? What is it where it's already helping them? And where is it where we need to do something different? And we, of course, like two companies using it already and helping us is the one thing, but we always look for more companies, for more input on how can we make this solution even better. So we are in Hall 6. It's where the startup area is based. Booth F187, it's right next to one big crane holding a car. It's not ours, but it's right next to it. And if you want to stop by, if you want to see the Fischer Technik factory live and want to start your own process, stop by. and we will have a chat about the IT miner, process mining in general, and maybe how you can participate in developing and enriching the solution itself. Thank you so much.
Awesome. Achtung, Lukas. Sorry, Lukas.
Oh.
I come from here.
Yeah.
Sorry for that. Thank you for the speech. Thank you for the topic. The interesting thing is, I have a lot to do with process management, and I saw so many startups coming to the end that are producing digital twins because they didn't have access to sensors, etc. That was in the beginning a big topic. So I'm super glad that we have a solution in place now that probably solves one or two of these problems we had in the past. So we have some very good questions, in my opinion, and something that might be interesting for the companies that are interested in your solution. Mm-hmm. What is implementation effort and time typically if you want to use your solution?
Yeah. So I would need to split it in the two topics of like the normal process mining platform that we have out there, which if we start for something like purchasing, which is a very common process to start with, we're talking about a day. One day. Because data is already there, and we just put it in software, and purchasing is something that is very easy for the software to analyze. For IoT, for the IoT miner, of course, it's in an alpha phase. It's currently being in development. It's something different, and it always has the hurdle of, do you already track different sensor data? Do you track the different sensors? Because if not, we need to bring in someone to track the sensors, because we are not tracking, we are not doing something like Backoff to track everything that is happening there. Yeah, so that's where we have done partners. But if you do track the different sensor data, you do write it into a database, it's 5 days, and then we have first results and can talk about the results and start to really go into the next step of adapting it to your process.
So it might be the case that you have like a step in between where you need to probably also bring several more interfaces to the machines in order to extract the sensor data as well.
Yes, if you are not collecting any sensor data at the moment, there might be specific interfaces, there might be specific software, hardware that you need to plug in to track how hot is the machine, how fast is it moving. Yeah, that's the one part.
Are you there partnering with companies that are offering these solutions?
Yes, we have some partners out there, some German ones, some European ones that are also doing that part of integrating this hardware and software solutions.
Very good, very good. So the question is, I mean, after implementation, the question is, can it be done in real time afterwards? Because if the process is set up and running, this would be a big advantage of doing a real-time analysis.
Yes, so we always talk about near time, because real time, in a sense, for the transformation that is needed, is not really possible. We talk near time in that case being like a minute late, 30 seconds late. Yeah, but we are talking about, we are not in a predictive maintenance area where we need to have it like real time, because otherwise the machine is going to have a failure. It's going to be, you will have it a minute late, knowing, okay, what were my main problems in the process? And then I can react and change something in the whole process. So we talk about near time.
One probably is a kind of critical question. There are big companies like Celonis, for example, that are doing process mining. I guess they're putting AI in place as well. So what is your big advantage?
So the big advantage for what we are doing is we always include our solution into the infrastructure or the environment of the company. So you're not uploading anything into our space, into our IT infrastructure at all. Everything stays at the company's premise. If they have a cloud, of course, it will stay in their cloud. If they have an own server anywhere, then it will stay there. So that is like the biggest advantage for what we see when companies talk to us. And then also, using all the sensor data, that's really like our unique selling point for manufacturing at the moment. There's no one else out there doing it.
Awesome. Lukas, thank you so much. Excellent presentation, excellent answering the question. Big applause, ladies and gentlemen.
Thank you.
And good luck for your activities here.